Right, so state the laws of equilibrium, I think you have that one, so I'm just going to concentrate on this middle bit. So the sine weighs 400 newtons, it's suspended at the end of a uniform horizontal rod. The rod touches the wall at position X, which is in the picture. The rod weighs, okay, so the weight, where is that? The rod weighs 330 newtons and is 1.2 meters long. Okay, so if it weighs 330 newtons, the weight is going to be a downward force acting through the center of gravity. So if this entire thing is 1.2, that means this side is 0.6 and this side is 0.6 because it's through the center of gravity of the rod, which is the middle. Yeah? So calculate the clockwise moment acting on the rod due to the weight of the sine and the weight of the rod about X, and then calculate the tension. So I don't know if you got the first part, but basically both of these forces, these two here, are pulling down on the rod, and if the rod is fixed here, then they would cause the rod to go in that direction, which is clockwise. Yes, it is. So that's clockwise. Okay, so the two of them together will make the clockwise moment. The moment is force by distance from fulcrum, and in this case the fulcrum is X. So it's going to be 330 by the distance from X, which is 0.6, and 400 by the distance from X, which is 1.2. And 0.6 plus 400 by 1.2. So that's 678 Newton meters is the net or the overall clockwise moment. Okay, hence calculate the tension in the cable. Okay, so, right, now we need the upward force and we don't have the forces. Okay, so basically, if it's in equilibrium, then the overall upward, or not upward, what's the word? Anti-clockwise moment needs to balance out the clockwise moment, yeah? So the overall anti-clockwise moment must be 678 Newton meters as well, and that way they'll cancel each other out. Yeah? So, I don't want the moment though, I want the force. I want the upward force because, sorry, I didn't say that, but tension is a force. So the tension in the cable, which is acting kind of in that direction, holding, that is a force. So I need to know that. I'm sorry, I'm trying to point here. I need to know the force acting in this direction because that's the cable and that's what I want. But I can't, like, I'm going to make a triangle here, like this. But I can't calculate the force in the highlighted yellow line if I don't have a force in the black arrow. And I don't have a force, I have a moment. Do you know what I mean? Right, but we can figure it out. Because moment is force by distance. The moment is 678, and we know the distance is 1.2. So if I just divide by 1.2, I'll be able to work out that force. 678 divided by 1.2 is 565. 565, and that's now a force, so it's newtons. So now, sorry, I'm not going to use the moment because the moment doesn't help me. I'm going to use the force. Yeah? So I have a little triangle then where, am I still on the page yet? This is 565. This is what I want. This is 90 degrees. Now this I can calculate because if I go back over here, it's just the other half. Not the other half, half's a bad word there, but you know what I mean? It's the other bit of the 90. So if I do 90 minus 35, it's 55. So this angle here then is 55. Yeah? So this is the hypotenuse. This is the angle, meaning that's the opposite, and that makes this the adjacent. So I don't want the opposite because it has nothing on it and I don't need it. So that means it's A and H. So using SOHCAHTOA, A and H gives me cos. So the cos of the angle is adjacent over hypotenuse. You can use either method, the flippy method or just algebra. So I'm going to use the flippy method. So the thing I'm looking for is on the bottom. So I'm going to flip this and I'm going to flip this. So I get 1 over the cos of 55 equals h over 565. And then I want to isolate h, so I'm going to multiply by 565. And I'm going to multiply here by 565. So 565 divided by the cos of 55 is a hypotenuse of 985 newtons. So the tension in the cable is 985 newtons. And that's to counterbalance a force of 565 newtons down, but obviously at an angle. So it's going to be under a much bigger force because it's doing it at an angle. Yeah. So let me know anyway if that's still an issue, but hopefully that makes sense.